Alright, so in section 3, we're going to get started by talking about things called logarithms. So in the past, when you guys have been on your calculator, you may have seen a button that says log, L-O-G on it. And if you've wondered like when that comes in or when are we going to use that, we're going to start seeing that show up here in the next couple of sections because we're going to be talking a lot about logarithmic functions and equations, and we'll also get into like some of the properties that logarithms have and how you can actually evaluate using them. So logarithmic functions and exponential functions are considered inverse functions of each other. So we talked about inverse functions last section where it's basically like the reciprocal of a function, like you're taking it, you're reflecting over that line y equals x. So when we did our exponential functions in section 1, you know, those are the ones that go straight up or they come down, like they have kind of that trend to them. The log function is when you take that and you reflect it over that same line, y equals x. So on a graph, here's what it would kind of look like. Okay, if this is my graph here, an exponential function would look something like this, okay? So we could call this y equals 2 to the x power, okay? And so that would be an exponential function because you're raising 2 powers, and so that's going to cause it to increase quickly over time. So remember that line yesterday I showed you guys that went through the origin? That y equals x line? That's acting like a mirror here. So it's going to reflect that exponential function over that line to get you what we call the logarithmic function. And so that's going to be the inverse of it. And so they're going to look similar, they're just going to be mirror reflections of each other. So it's going to look something along the lines like that. Okay, and so how we would write that as a logarithm is it would be y equals log with a little 2. So instead of like an exponent 2, it's a subscript now because it goes below and then x. So we're going to talk about how do we get from something in exponential form to something in logarithmic form. Okay, because depending on where your number is or where your letter is going to change where it's at in the log function. They have a specific relationship with each other, and so you can always go back and forth between the two of them just by looking at their equations. You don't necessarily even need the graphs to do this. So we're not going to be doing any graphing today. We're just going to be looking at the function equation itself and talk about writing it either in logarithmic form, or if it's in that log form, we're going to change it back to exponential form. So right underneath this, where I kind of drew that in, this kind of goes over how they expect you to do that. How do they expect you to convert back and forth? So if you have something in exponential form, that means that you have a number which is your base raised to an exponent, your power, and that's equal to some amount. So it would be like 2 to the 3rd power or 2 to the 4th power, because that changes depending on what number you're putting in for the exponent. To rewrite it as a log function, you always have that word log. Your base, so the number that you're raising to a power, that becomes that subscript. The amount kind of becomes before the equal sign instead of after, and then you have it equal to your power or equal to your exponent. So looking at these two forms here will kind of help you see where things get moved to in the two equations. And it'll take a little bit of time for you to get used to where they go, but once you figure it out, it's the same for all of them. So then they give you a specific example. They say if you had something like b to the x power equals a, that would be an exponential form. If I want to write it in log form, we would do log with the b, the base, then your amount, a, and then equals x, that power. So the value of the log is the power of the exponential. So the logarithm, if I actually evaluated it, that's going to give me the answer that I would get if I took my number raised to that exponent. So let's do some practice here. We're going to start by first rewriting logs as exponential functions. So this first one says log 2, 64 equals 6. So I need to write it as something raised to some power equals an amount. So the base is this subscript 2. So you're going to pull that 2 out. That's going to be your base. The equals 6. 6 is the exponent, or the power. So it's going to be 2 to the 6th power. And then you're going to say equals, and you're going to have that 64 kind of go behind the equal sign now. Okay, now if you actually check that, if you had a calculator, do 2 to the 6th power. So like type that in. 2, use your caret key, 6, hit enter, you should get 64. Okay, so that kind of lets you know that you set it up right, because this should be a true sentence here. This should evaluate out, and it should balance out on both sides. Okay, so how would I rewrite number 2? Anyone have an idea? Good. 3 to the 4th power equals 81. And again, you could check that. 3 to the 4th would be 3 times 3 times 3 times 3, and that should get you 81. Okay, so you guys try to rewrite 3 and 4 on your own. So for number 3, you should have had 5 to the 0 power equals 1. For number 4, can someone tell me what they wrote down? Close, not quite. You got to switch 2 things around. Say that again. Yeah, so -1, you want 7 to the -1 power equals 1 over 7. In like algebra, when you guys probably talked about exponents, and we did talk about this earlier this year, like at the very start of the year when we were kind of reviewing, we talked about negative exponents and how you can't have negative exponents. So when you see something like that, 7 to the -1, you drop that number to the bottom of the fraction because that makes it become positive. So that's why you have a fraction in this one. Anytime you have a negative exponent, you're going to see a fraction in your answer because they're going to have to drop that portion that's got that negative exponent to the denominator. In this case, there's nothing else in the problem, so that's why they put a 1 on top to just kind of hold that place for you because it's not a 0. It's going to be a 1 up there. All right, moving on then to the next couple of examples, we're going to go the other direction. Okay, so they're giving us something in exponential form. We want to write it in log form. So for this first one, I have 9 squared equals 81. So remember, for the log form, you start by taking that word log. Go ahead and just write that down. You take the number that's your base, which is the 9. That becomes a subscript. So it's like a small 9 that's down next to the G. It's not an exponent. It's different. Okay, then you bring the amount that it was equal to. So 81. That comes before the equal sign, and then it's equal to your exponent, or your power, which is 2. So it'd say log, little 9, 81 equals 2. Okay, so you guys try to rewrite 2 and 3. I guess there's a 4 on the back side too, if you guys want to try that one as well. All right, it looks like we're getting this figured out. So we have log 4, like a little 4, then bring over the big 4, and that should have been equal to 1. For number 3, we've got that negative exponent again, which is why there's that fraction. So it's log 5, bring over the 1 over 25, and that should equal negative 2. And then on the back side of that front page there, this last one should say log 15, whoops, little 15. Bring over the 1 equals 0. All right, so now that we kind of know how to write back and forth with them, what we can do now is work on solving. If it's written as in like a logarithmic equation and something's missing, so like the power's missing or the amount's missing from the problem, we can rewrite it as an exponential equation and then solve it. We can solve for that missing piece. So like this first one says log 5, 25. And normally, like in the past, we saw that it would say like equals a number. And this one doesn't have that. So what I start by doing is say equals, and I put a variable, x, because that's the piece that's missing. So then I'm going to rewrite this as an exponential problem now. So I'm going to change it from the log to something raised to a power equals an amount. So my base is that 5, that little 5. X is my exponent, or my power, and this is equal to 25. Now some of them you'll know, like you'll be able to just say, oh, I know what x should equal because I know 5 times 5 is 25. So I know if 5 is squared, I'm going to get 25. So in this case, what it really means is if I rewrote 25 as something with a base 5, it would be 5 squared. And so when those 5s match now, like my bases match, what I can really do is kind of think about them going away, and I'm left with x and a 2. And so that gives me my answer for x. You don't necessarily have to show me that step, because like I said, some of you, most of you probably know that 5 squared is 25. So you can already just say x is 2. X has to be 2 in order for that to be a true sentence. Okay, so we're going to do something similar with number 2 here. We're going to take, again, set this equal to like an x. And then I'm going to rewrite it. So it's going to say 2 to the x power equals 64. Okay, so again, if you don't know it right off the bat, then you might have to do some guessing and checking. Like you might just have to start taking 2 and raise it to a 4 or a 5 or a 6 and see if one of those works. If you take 2 and you raise it to the 6th power, that should get you 64. So this one, x is going to equal 64. I'm sorry, not 64, 6. X is going to equal 6. Okay, I want you guys to try the last 2. And I'm going to tell you right now to be careful with number 3. Okay, because there's a fraction involved, which means you have a certain type of exponent. And if you don't remember, look back on previous examples because we saw some that had fractions. And I talked about those exponents briefly with you. Okay, let's go ahead and finish these up. So number 3, you have 4, if you think about this as like equal to the x power. So 4 to the x equals 1 over 64. So when you're doing this, because you have a fraction, you're going to have a negative exponent. Okay, and so I saw a lot of you figured it out that you got x has to equal a negative 3. Now, if you actually typed it in your calculator, 4 raised to negative 3, you're probably going to get a decimal of some sort, but it should match. Like if you took 1 divided by 64, those two decimals should match. The other thing that you can think of is like 4 to the 3rd power would be regular 64, so then to get the fraction, you just have to make that number become negative. For number 4, what'd you guys find x to equal for this one? 3 to what power is 243? Good, 5. So x equals 5.